It causes less problems when I do it first. Let me go ahead, and I've got to do everything on this screen because I don't have my TV plugged up anymore. I've got the projector plugged up, and I haven't got everything fixed yet. So y'all just have to bear with me. Okay, hopefully y'all see, did y'all see the Word document I posted?
Yes.
Okay, make sure you print that out. I did put some of 10.10 or 10.11, whichever the inverse trig functions. I put that up there. That's basically all I'm going to test you on right there. But we'll hopefully get to that. But here is the problems that I didn't feel like writing the other day. And here's the first one. And I'll let y'all write it down right quick. And then I'll put the document cam up. The sides of a square decrease in length at a rate of 1 meter per second. At what rate is the area of the square changing when the sides are 5 meters long? At what rate are the lengths of the diagonals of the square changing? So, excuse me. First thing we're going to do, and I'm going to try to move this over to where you can see. Is the sound a little bit better, or is it still choppy?
Sounds much better.
Okay, I have no idea what caused that. I'm going to try to pull this down as y'all write down the question. And you're going to draw a picture. So, of course, we're going to draw a picture of a square. And this is a test question. Okay? So, we've got X and X. And we'll call this, and most people call this D. We're going to call it L because most of the problems that we do with rate of change, you're going to have an X, Y, and usually an L. Of course, you don't have to use L. You can use anything you want to. Now, the area, of course, of a square is equal to S times S, or S squared. So we want the rate of change of area. Rate of change of area would be dA over dt. So I'm going to take the derivative of that in respect to t. So dA dt is going to be equal to 2x or 2s, whatever you want to call it, dx dt, or d prime, and that's our formula we're going to be working with. So the first part of the question says, A, what if x is equal to 5 meters? And dx dt is equal to -1 meter per second. Now, remember what I told y'all about rate of change. You're going to find this out in second calculus. A lot of times, rate of change is nothing but plug and what? Once you got this guy, it's just plug and what?
Chug.
Chug, Hubert. That's right. Okay, I made a mistake. S. I don't know why I did that. I'm sorry. There we go. X. There we go. So if I want to find A, my rate of change of the area according to time is going to be equal to 2 times 5 times -1. Now, if you wanted to get technical, that's going to be meters, and that's going to be meters per second. So our final answer is going to be -10, meaning it's decreasing, meters squared per second. So that's A. So the first thing we did was find our formula. And most of these basic questions that I will ask you on a test is going to have to do with area or perimeter or something like that. So we're going to do this in pink. First thing you do is find out your formula. Then after you find the formula, you take the what? You take the derivative with respect to t. And then usually they're going to give you some plug and chug. Plug and chug. Now for B, I keep trying to use my mouse, but I unplugged my mouse because the wireless mouse was messing with the pen. It's going to take me a couple of days to playing with this thing to get it right. At what rate are the lengths of the diagonals of the square changing? Well, we all know what the Pythagorean Theorem is. So I'm going to go to the next page.
Oh no, what's the Pythagorean Theorem?
Nobody knows it. You're supposed to forget everything right before calculus. Y'all know that, don't you?
Then I'm in the right place.
Okay, good. That way you can fail calculus. Get everything you learned before calculus. All right. So we know that B, we're going to be using the Pythagorean theorem, which says L squared is equal to x squared plus x squared. Most of the time we're dealing with y squared, but in this case it's a square. So L squared is equal to 2x squared, or L is equal to the square root of 2 times x. Now we got another formula. What do we do with the formula after we get it? Let's go back. What do we do after we find the formula? You take the derivative of it, Hubert. That's right, class. dl dt is equal to, the square root of 2 is a constant, so that's just like 4x. So what is the square root of 2x? What's the derivative of the square root of 2x? What's the square root of 4x? I mean, what's the derivative of 4x?
4.
So what's the derivative of the square root of 2x?
1 over the square root of 2.
Just square root of 2.
1 over 2 times the square root of x. Sorry.
Just square root of 2. Remember, if I give you f of x is equal to 4x, then f prime of x is equal to 4 because 4 is constant. Okay? What you're thinking of, and what people get this one mixed up with, they think this is this. And these are two different animals. Okay? The square root of 2 times x is the same thing as 4x. The square root of 2 is a number. So and this is dx dt. Now, of course, we know that dx dt is -1. So plug that in. So our length of our diagonal is changing at square root of 2 meters per second, and it's decreasing. Now, the reason I like this question is this KISS method. And what's the KISS method?
Keep it simple, stupid.
Keep it simple. Okay? There is nobody in this classroom that doesn't know the area formula and the Pythagorean theorem. Now, some of y'all will find a way to mess this up. Okay? Okay. That's a good problem. Now, the next problem we already did, but y'all got it on your sheet, so you can see how it's written. Okay, so make sure you make a note of that one, and that's the boats. Please make a note of the boats. I'm not going to go over that one again. And then you got the third one, so write that one down. If you don't, I'll show it to you right quick. So, all right, there's the third. Okay, at what rate is the liquid being sucked out of a cylindrical glass that is 6 inches tall and has a radius of 2 inches? The depth of the soda or liquid decreases at a constant rate of 0.25 inches per second. Oh, the depth of soda decreases. That sounds like a dx. That sounds like dx dt maybe, or dh dt. Since it's height, that would be dh dt. So if I were to do anything, the first thing I would do before I draw my picture is I would say, whoa, wait a minute. Here is my dy dt. So I'm going to go right there and I'm going to put dy dt is equal to -5 or -0.25 inches per second.
Are we supposed to be seeing something?
I'm sorry. Hold on. I can't switch everything over. Sorry. There we go. I got to turn this thing off. I've got 2 or 3 things running at one time. Let me turn this off too. Give me a second. I'm turning some things off. My mouse, I can't catch my mouse. Mouse is going all over the place. Now, what kind of formula do you think you're going to use on this problem?
Volume of a cylinder?
Well, I done lost my, yes. You're going to be using the volume of a cylinder. That's the formula you're going to be using. Because what did they give you when you started off? Inches cubed. What's cubed? Area or volume? Volume, Hubert. That's right, class. Now remember, 11 point, whatever, what section we on? Chapter 3? 3.11. is your Unit 1 test as well. It's going to be part of the Unit 1 test. It's going to be more problems. But get used to it because that's Unit 1 test in Calc 2 is this. So I'm going to draw a picture. And my picture is going to consist of a cylinder and 6 inches tall and 2 inches radius, 2 inches radius. And I know that dH dt, my rate of change on my height of my liquid is decreasing at 0.25 inches per second. So all I need now is a formula. Well, the formula we're going to use, since they gave it to us in volume, the inch cubed, we're going to use volume. Volume is equal to pi r squared h. And you're going to give me dV dt. All right, go to it. Find the derivative of dV dt. So that's going to be, well, 2 times pi times r, right? So that's going to be 2 pi r, 2 minus 1 is 1. And then d what? dH dt. Wait a minute. We have dH dt. dH dt is right here. So now what are we going to do after we found our derivative?
Plug and chug.
Plug and chug. And remember, right here, I want to bring something. I don't want y'all to have a brain bubble on me. What is pi?
A constant.
Okay, so I'm going to go over here. I want you to tell me what the derivative of 2x squared is. What's the derivative of 2x squared?
4x.
4x. So the derivative to 2 times 2, 2 times 3.14 is right there. So I don't want y'all to go crazy on me. So dV dt is equal to 2 times pi times 2 times negative 0.25 inches cubed per second. And somebody crank that out. What do you get? Well, doesn't the 4? Yeah, the 4 cancels. The 4 cancels with the 0.25, doesn't it? It should be 3.14. Somebody check me. 4 times a quarter is 1. So negative pi.
Yeah,
Somebody check
pi.
it.
Negative pi.
Okay.
I'm still stuck on the derivative of pi r squared h. Wouldn't that be the product rule?
No, this is a constant.
Right, but pi r squared and then h.
Shoot. You're right.
I'm sorry, I hate to be this way.
No, I shouldn't have made the mistake. That's what happens when you have notes. Next time I need to look at the damn notes. Sorry. Pi r squared h. So that's going to be dv dt is equal to, and you can take this to make this 1 first times the derivative of the second plus the second times the derivative of the first. Y'all check me on that. And that's going to be dv dt is equal to, it comes out to be the same, pi r squared times dh dt plus 2 pi r. Did I take the derivative of this one? That would be, yeah, put the derivative. 2 pi h r. Y'all check me on that.
Mm-hmm.
Okay. Do you come out with plug and chug after that? Because that's going to be dv, sorry, is equal to pi r squared times negative 0.25 plus 2 pi times 6 times 2. dv dt is equal to, and they're going to put 2 in here, that cancels. That leaves pi plus 12 times 2 is 24 pi.
Mm-hmm.
I don't think this is right. dv dt, I'll have to look and see. 25 pi, because I would think it would be decreasing, would it not? What rate is soda being sucked out of a straw? No, it'd be positive because the depth is going down, so that could be correct. I'll have to check on the answer on that one. Let me check on that one. Did y'all get 25 pi?
If
Wait a minute, that should be negative. Should be
That
negative
first
23 pi.
Negative.
That's decreasing.
Decreasing. So that'd be negative here. Negative pi, would that be 23 pi?
yes.
Okay. Let me check on that answer. I'll have to check to see what the example says, because I thought it was pi. I'll check that one. Okay, next one. The process is all that matters here. The next one, y'all read it off. I'll get it off of your Word document. Hold on. It's the hot air balloon. I ain't kidding you. This mouse is going freaking crazy. I don't know what's wrong with it. Y'all have to excuse me. What am I pulling up? Word. So go down. There it is. An observer stands 300 feet from the launch site of a hot air balloon at an elevation equal to the elevation of the launch site. That means it's level. The balloon is launched vertically and maintains a constant upward velocity of 20 feet per second. So dy dt is 20 feet per 1 second. So write that down. dy dt is equal to 20 feet per 1 second. And you don't have to write it like that. I just wrote it like that because it's 20 feet per second. What is the rate of change of angle? So that means we want d theta dt.
We can't see what you're writing.
I know, I'm gonna turn it, I'm reading it to y'all right now.
All right.
Okay. The balloon is, maybe I could just make it small. I'm just writing down what they're giving us. That's what y'all should be doing. Okay. The balloon is launched vertically what is the rate of change of the angle of elevation? That's the person watching how they turning their head up or their eyes up. That's the angle of elevation. When it is 400 feet from the ground. So let's draw a picture. Draw pictures 300 feet away. Here's your person. And there's a dang old balloon. Okay. So we've got 300 feet here. We've got theta, and this is going to be 300 eventually, or 400. Is it 400? 400 feet up. Eventually, it's going to be 400 feet up. But we already got dy dt. We know we're going to be looking for d theta, so that means we got to find something. We got a trig function here. Tan of theta is equal to y over 300. Now, yes, you could use anything you want to of the three trigonometric functions, but I'm using tan because that puts the 300 on the bottom, which is easy to solve for y or theta, either way. Okay? So if you want to go ahead and solve for theta, that'll be your formula. Theta, what's the derivative of theta? D theta dt. So theta is equal to the inverse tan of y over 300. And we're going to get into that in just a second. Because inverse tan is nothing but plug and chug. What?
When you get done with this one, I figured out how they did the last one.
Okay, well, isn't it supposed to be pi?
It's supposed to be pi.
Okay, that's what I thought.
Treat radius as a constant, not a variable.
That's what I thought. I thought because it doesn't change. You plug in the number, it doesn't change. Okay. Okay, I'm sorry. All right, so anyway, so this is your formula. I want you to go through and take the derivative. Now, before you do that, let's look over to the derivative of tan, the inverse tan. Because all it is arctan. There it is. So I want you to write that down. U prime over 1 plus u, and u is what's in the middle. And in our case, u is equal to y over 300. I'm sorry, yeah, 1 over 3, y over 300. Now, and you also got to take the derivative of y over 300 too. Now, if you use the derivative of the arctan, and we're going to go over this today when I finish this problem, dt is equal to 1 over 1 plus y over 300 squared times 1 over 300. And that comes out to dy dt. And that dy dt is going to be 20. So you get d theta over dt is equal to 1 over 1 plus y over 300 quantity squared times that 20 goes right there. So that's going to be 20 over 300. And when that y, let's see, that y is supposed to be 400. I'm sorry, 400. When you crank it out, it's supposed to be 400. And when you crank that out, it comes out to be, and don't just hold this one until we get to the next unit, okay? Just bear with me. And that's going to be 0.024 radians per second, because we're going to do another one like this one at the end of 3.10. So just hold this one to the end of 3.10 and hold, we're going to do another one at the end of 3.10. Okay, now 3.10. Now, out of those questions, those three questions, oh yeah, this right here. Let me go back over this one because I knew it was pi. There it is. When you plug that R in, that R becomes a 2 right there. And I think that's why, I think they treat it as a constant. Comes 4 right there, 4, and that's why. Okay, out of those 4 questions, the first 3 are good test questions, because I would do this, I would use this question on 3.11 or 3.10, okay, which we're fixing to do. Everybody with me? So now here's 3.10 coming up. Now, to do 3.10, you have to know the arctan and I meant the 6 trigonometric. There we go, right there. Okay, just like the arc sine. Sine to the -1 is going to be u prime, which most of the time u prime is 1. Okay, it's going to be 1 over the square root of 1 minus x squared. Some people put u, some people put x squared. I think your book does x. Okay, the derivative of x is 1. And that's usually going to be 1. These are usually going to be 1s unless you have something like 2x, and then it would be 2. So write those down if you haven't already wrote them down. I'm going to show you one derivation, okay? I'm going to show you one of the ways to get the sine, but I'm not going to show you with the sine and the tangent. I've got them, but I'm not going to do all that because I don't really think that's important. I think it's more important that you know how to use them. So, y is equal to the inverse sine of x. And that goes from -1 x to 1. So I could rewrite that as x as its inverse equal to the sine of y. And that y being from -pi/2, -pi/2 to pi/2. Okay, inverse. I'll just write inverse. Okay, and if I took the derivative of x of this function right here, if I took the derivative of that, that would give me x prime, which is 1. I'm sorry, 1 is equal to cosine of y dy dx. And then, of course, solve for y prime or solve for dy dx. You get 1 over cosine of y is equal to dy dx. This is just a derivation.
Can you scoot the paper down a little bit? I think I'm missing something.
Okay, you started with this. That was dead. Okay, I'm going to put derivation over here because this is all derivation over here. I'm not going to do it for all the other ones, okay? And you can look in your book. They probably have the derivation in there. Derivation, not taking the derivative, but showing you how the derivative of sine, the inverse sine is equal to u prime over the square root of 1 minus u squared. Okay? So, according to our handy-dandy Pythagorean theorem, cosine squared plus sine squared is equal to 1. And if you solved it for cosine, you'd get cosine is equal to positive or negative square root of 1 minus sine squared. Okay, everybody agree with that? So I can plug, and since that cosine of y we want to keep greater than 0, we're going to keep it positive. So I'm going to plug the positive in for cosine, and that gives me 1 over square root, positive square root of 1 minus x squared. Because technically you could say that the sine is x squared if you solved it right here. Okay? So basically, the derivation, the derivative of y is equal to the inverse sine of x is equal to, and you can write it like this if you want to, dy dx is equal to 1 over the square root of 1 minus x squared. And all you're going to do is plug and chug. And I'll give you some examples. And now I'm going to tell you something right now. I'm not going to ask you a question on the test trying to find out the theory behind this. I'm just going to give you a problem. It's going to say y is equal to the inverse sine of 2x. And then you go down here and you say blah, 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 and you plug it in. We're going to do something in a minute. I'm not going to ask you to give me the addresses of the people who attended the U.S. Open. Okay? Here's an example. Here's 2 examples of test questions for what section is this? 3.10 A. And you're only talking about 2 or 3 questions. Find the derivative in respect to x of the inverse sine, that one's dead, of natural log of x. That one's dead. Get rid of all my dead markers because I threw everything in the floor and got to get rid of some of these markers. So remember, let's take a minute and recap. What are these things called? Parentheses. What's inside? Chain rule. So the derivative of what's inside. So we're going to plug and chug. And I'm going to plug this in. The sine is 1 over the natural log. I'm sorry, not the natural log. The square root of 1 minus parentheses squared. And then, of course, we got parentheses here. So I'm going to add pink parentheses and take the derivative of that function right there. So here I'm going to plug in natural log of x. And what is the derivative of the natural log of x? And now clean that up. I don't care. You can clean it up. That's going to be 1 times 1 and x times this. So that's going to be equal to 1 over x times the natural log of 1 minus natural log of x squared. I meant square root, sorry. Now that's not difficult. Okay, try this one. I'm going to let you do this one. Again, another test question. Inverse sine of e to the negative 2x. Well, I'm going to add some parentheses right here because that's the parentheses you got to use chain rule with. Well, I know that the sine is 1 over the square root of 1 minus parentheses squared. And then I've got the derivative of what's inside those parentheses I've got to redo. Now, if this was just x, if this was just a positive x, then you wouldn't need to do anything because x is 1. But if that's a negative x, if it's a negative 2x, if it's 5x, you got to have parentheses. So the derivative of negative 2x is what? Negative 2, Hubert. Thank you, class. I appreciate y'all's helping me out. Makes the guy happy to know his class supports him. Y'all suck. E
I
to the
give
negative
up.
4x.
I don't know if they're
What? Y'all suck. If you want to put parentheses around that, you can. Now, please, people, don't make these difficult. Because I'm not going to. Because I'm going to tell you right now, half of your calculus 2 unit 1 test and unit 2 test is going to be a lot of plugging and chugging. A lot of it. And you're going to get that first plugging and chugging, you're going to say, Hubert told us we were going to be doing this. If you're not totally lost by a teacher that don't know how to teach. Y is equal to tan negative 1 of x. Now, I can go through the derivation, and I could say x is equal to tan of y. And I could go through the derivation and get, I could do 1 is equal to secant squared of y dy dx, and then solve for dy dx. That would be 1 over secant squared equals dy dx. And remember, the secant squared is equal to 1 plus the tangent. So this is going to replace with 1 plus the tangent. And that's going to replace the tangent squared of x, or y, is equal to x squared. So that's going to be 1 over 1 plus x squared. And that's basically equal to dy dx. So let's look back at our tangent. Everybody look at tangent. 1 over 1 plus x squared. I don't know why I picked you. I'm sorry about that. So the derivative of the inverse tan of x is equal to 1 plus 1 over 1 plus. The cotangent is the only one that doesn't have the what? The tangent and the cotangent are the only ones that doesn't have the what?
Square root.
The radical. And I'll show you the secant. I'm not going to go through every single step. Y is equal to secant -1 of x. Well, that's going to be x is equal to the secant -1 of y. Secant, if you take the derivative of the secant, that's sec tan. So x is equal to 1, that'd be 1, sorry. 1 is equal to sec tan dy dx. And if you solve for secant squared, and solve for the secant, then you're going to get solve for the tangent, you're going to get 1 over the x squared minus 1. So you're going to get basically dy dx is going to be equal to 1 over, and that's going to be the square root of x squared minus 1. And if you look at the tangent, I mean the cosecant, I mean the secant. Where's the secant? There it is. 1 over absolute value, of x, sorry, plus or minus x squared minus 1. So learn them. Now here's an example of a problem you might see in Calc 2, because you don't have to do, y'all are used to seeing something like f of x is equal to 2x. What's f prime of x? Well, you got to use a property. That'd be 2. Or f prime of x is equal to 4 times x minus 2 to the 5th power. I'm sorry, f of x. F prime of x is equal to 20 times x minus 2 times 4 times 1. And you use these methods. Well, sometimes, that one's dead. Sometimes you can solve algebraically and find, and y'all found this out with implicit differentiation. And I'm just going to go over this one right quick. Inverse cosine of x plus inverse sine of x is equal to pi over 2. So take the derivative of it, and you get the derivative of cosine of -1x plus 1 over square root of 1 minus x squared is equal to 0. And all you have to find is this. So you just take this over what? To the other side. Remember how you find it? Remember this, because you will see this again. So the derivative in respect to x of the inverse cosine of x is equal to -1 over the square root of 1 minus x squared. That's just another way to get, well, given this right here, I mean, given cosine, inverse cosine of x plus inverse cosine of y is equal to pi over 2. You can actually just solve it algebraically, take the derivative, solve algebraically, and you get the derivative is equal to that. Okay? Or you could have went through and derived it like I've been doing it. But it wouldn't work as good on this one. That you need to do y is equal to cosine -1 of x, and then you could derive that like I've been deriving. They did it algebraically. Here's an example of a question I might ask on a test. I've already gave you 2 examples, those first 2. those first two simple ones. Here's another one. Find an equation. Find an equation of the line tangent to the graph f of x is equal to the inverse cosine of x squared at 1 square root of 2, comma, pi over 3. So they give you a point. This is your x of 1. This is your y sub 1. So you know you're going to use the point slope equation. So find your slope. Find your derivative. F prime of x is equal to, well, that's going to be negative 1 over the square root of 1 minus parentheses squared. And I'm going to have to use those parentheses again because look at there. I got something besides an x. If it's besides an x, you're going to have to use chain rule. So the x squared goes here, and the 2x goes here. So our derivative, f prime of x, is equal to negative 2x over the square root of 1 minus x to the 4th. Now, what are you going to do with that derivative? Because that's the equation of the what?
Slope.
Equation of the slope. So I'm going to take that equation and I'm going to plug in that x to get my slope. M is equal to negative 2 times 1 over the square root of 2 over the square root of 1 minus square root of 2 raised to the 4th power. Well, that's going to give you negative 2 over square root of 2 over the square root of 1 minus, well, let's do square root of 2 times square root of 2 times square root of 2 times square root of 2. I know it's easy, but let's just do it that way people don't screw it up, okay? Square root of 2 times square root of 2 is 2. Square root of 2 times square root of 2 is 2. What's 2 times 2?
16.
Okay? Don't do that because somebody will believe you. Negative 2 over 12 divided by 1 minus 4 is negative 3. And of course, we're going to get a positive slope.
What? Wait. Isn't that 2 over the square root of 2, not 12?
Okay, thank you. I guess I just thought that was a 12. Thank you. Okay, so negative 2. Is it okay if I do the negative times a negative as a positive? Is that good with everybody? Or
I
does it want to be negative? Square root of negative is going to be negative. What did y'all come out with? Did y'all come out with a negative or a positive? I came out with a negative. I'm looking to make sure I put everything right. Negative square root of negative 2 over square root of 2 times, that's over, it would be 1 over the square root of 3. But that's a negative. So I got negative 2 over square root of 6, that'd be negative. Supposed to be 4. Somebody check my math. See, did anybody get a 4 on top? And it's supposed to be negative. I've got a sign wrong somewhere. negative 2 times 1 over the square root of 2, square root of 1 minus the square root of 2 to the 4th power. I shouldn't have. Well, I got a negative 4 over the square root of 6. Somebody check me. That's what I got. Negative 4 over the square root of 6. But that's not what I'm getting right now. I'm getting negative 2 over the square root of 6. Or positive 2 over the square root of 6. I'm going to say that what I did before class was right. And then plug that in. Y minus pi over 3 is equal to negative 4 over the square root of 6 times x minus 1 over the square root of 2. And that you solve for y to get the equation. Y'all check me here. See if it's supposed to be negative 4 square root of 6, but I'm coming out with positive 2 square root of 6. And it's supposed to be a negative. I've got a sign in there wrong somewhere. And here is the last one. And this is small plane. This is like I told you. Small plane moving at 70 meters per second, or flies horizontally on a line directly over an observer. What is the rate of change of the angle of elevation, meaning vertical angle? That'd be d theta over dt dx, sorry, dx, because we're looking at x. When the plane is at x equal 500. When plane is at x equal to 500 meters past the observer. So you got the observer right here, and this is x, and this is going to be 400 meters. That's vertical. And then this is theta. And the plane traveling over the top of this person. The person standing here. Okay, and this is 70 meters per second. So we already know that we've got, let's see. Oh, this would be the tangent. Tangent theta equals 400 over x. So therefore theta is equal to inverse tan of 400 over x and plug and chug. So d theta dx is equal to, plug and chug, that'd be 1 over 1 plus 400 over x raised to the second power times negative 400 over x, because that is that right there.
Mhm. Wouldn't that be x squared?
Yes, sorry, thank you. No, that would be x.
The negative 400 over x squared.
Yeah. And when you do that at 500, you plug 500 in, that's going to be equal to, because that x squared is right here, you got to take the derivative of what's inside, 400x to the negative 1, that's where the comes out to be negative 400 over x squared if you forgot. Remember, what's inside the parentheses? I don't mean to insult your intelligence, but I guarantee somebody out there, where did negative 400 over x squared come from? Came from right here. Derivative of what's inside. Okay, so if you plug all that, theta over x, evaluated at 500, then that's going to be 1 over 1 plus 400 over 500 raised to the second power times negative 400 over 500 squared. And when you do the math, I got 0.000976. Somebody check me. Negative 0.000976 radians per second. Radians per second. Now you're talking 1 or 2 simple questions, and then maybe 1 or 2 questions that have to deal with finding an equation, or this one right here. And you already got another one. I gave you another one at the end of 3.10 or 3.11. That what was it? The hot air balloon. It used the tangent also. So technically, you got 2 questions you can look at. Let me find that one. I'm trying to find it.
And
Give me a second.
Time's up.
I know some of y'all are going to self-combust. Okay, that's the question goes with it. And do that question, do the same as that. Now, what did I just do? Let's go over this, because we need to go over this, because some of y'all need it. What did I just do? Come on, spit it out.
Math? What in
Okay, I
reference?
know that. What did I do as far as sections? Who is messing? Somebody's messing with my dadgum mouse. Please stop messing with my mouse, or this dadgum machine's doing it. One of the 2.
It's the Russians.
It is. What did I do, people? What section did I just finish?
3.10.
I just finished 3.10, and I've already finished 3. What?
11.
So what does that mean, people?
Test coming up.
We are done. And I guarantee you somebody's out there, what does that mean? I'm gonna leave it on. I'm gonna turn my presentation off, and I'm gonna leave it on recording because I want to record this. That means that tomorrow, without questions being sent, what am I gonna go over tomorrow?
The test.
That means that I'm going to go over the test tomorrow, and that means that chances are the homework will shut off on Thursday. Wednesday. I give you one meeting after class, after the review. So that means Wednesday midnight is when the class is going to, oh my Lord, we already got people talking.
Does that mean we can work on it until Wednesday?
Where's my
just
cat? I
open.
don't have a cat. You're gonna have questions up until midnight Wednesday night. Okay. So that means that tomorrow we're gonna go over a test, and then I will set the dates for the test, and I will set the dates for the homework. Okay.
Awesome.
You mean reset the dates because they're supposedly due
I
tonight.
shouldn't have to. I'm not going there.
Well, the dates for the homework right now today.
I'm going to look.
Yeah, they're due tonight is the only thing, and I'm like, we're still struggling with the 3.10, 3.11. I sent questions today.
Okay, we'll go over those tomorrow. You didn't send them before class. I had one for Mr. Luckner.
I promise.
You must have sent them right before class then. What time did you send them?
Lunchtime.
I didn't see them. They must have got tied up in the Tri-County Tech vortex. Let me look right quick. Okay, you sent 3 questions, and I got one for Mr. Luckner to go over. I got one for him. Mr. Luckner, are you out there? He didn't even come to class. He's in the ditch somewhere. All right, got 4 questions to go over, and Mr. Luckner got a question for him. But that's 5 questions. So we better speak
And I'll
now.
have one for you by the end of tonight.
So that means I got to go over those questions first before I go over the exam. Okay. Okay. All right.
We will have until Wednesday to do the homework. Or
I'm not sure. What time does homework cut off?
Right now,
Today.
midnight tonight.
At midnight.
Okay, that's what I gave y'all 2 weeks ago, right?
right.
No, these were like last
Okay.
ago. These were more.
Come on, be truthful. When did I first assign those first 3 sections of homework?
What first 3 sections?
3-1, 3-2, 3-3, and 3-4.
Oh, those are all done. We're talking about 3-7
Okay.
or 3-6, 3-8, 3-10, 3-11.
Well, there's some people out there that's asking for me to reset all of them, and I'm not doing that.
No, just the 3, 6, 8.
No. Just the reviewed ones.
The
Okay.
revised ones, the ones that
revised one.
that we had to
The
redo.
ones that I just went over the last few days.
Yes.
Okay.
Correct.
Yeah, I can handle that.
Awesome.
All right. Any other questions? I'm gonna shut off the recording. All right. Y'all get out of here, and I will see y'all tomorrow. And I don't know if I'll have this thing ready or not, but I'll try. We'll have a test tomorrow and questions to go over. So keep sending them.
Can do.
See y'all.
Have a good one.